Hi there, thanks for coming today. My name is Kyle Sword, and I'm the Manager of Business Development for NSG Pilkington in North America. Today I'm going to be talking to you about lowering the carbon footprint of windows with emerging technologies. So, it's not green day like I've got on the bottom left there, or green glass, but it's green in terms of environmental and sustainability. How do we help architects and designers achieve some of the targets that they have in terms of their green and sustainable goals? So what I'm going to try and teach you about today is, some of the emerging and available technologies out there and how they impact both embodied and operating carbon, and really how you can start to think about some of these things in terms of your design. So first off, for discussion and scope, I do not work for an engineering company. I am not a consultant in terms of environmental or embodied carbon. There's a number of great firms out there that do EC3 and Tally and all these different calculations. Great architects that do design work and sustainability, and I'm not one of those. I don't intend to be, but I can point you to the direction of some of those people if you need some help. I'm also not a historic preservation architect or a historian or preservationist, but I do get involved with the restoration of existing buildings quite a bit. And honestly, I'm just a glass nerd. I like the science of glass and glazing, and I try to help educate people in this space. And today, what I'm going to be talking about is the applications of these products, not necessarily about the manufacturing of glass. I'll mention it a little bit, but we could spend a whole hour talking about how do we help glass manufacturing become greener. And there's a number of activities that we have, but the scope of today is just really the use of these products that we're making. And really what I'm going to try and do is help you talk about some of these emerging technologies and show how preservation and preservation technologies are really already starting to show the path for how do you achieve some of these climate change goals that we have and the targets of architectural world, and use some of those solutions that are pretty much already available. So first, I'll try and set the stage with some of the definitions. I think, at least in the U.S., most people are going to be familiar with this 40% number that I reference. And this is, of the energy that gets used in the United States, about 40% of that energy goes into the operations or goes into buildings. But really, that 40%, 2/3 of that is actually from building operations. So that would be operating carbon. And that's the stuff that we're typically very familiar with is how's the energy perform? Is it a good insulator? What's the heating and electric bill? All those sort of things. Embodied carbon is this thing that doesn't often get talked about, but it's essentially how much energy goes into the manufacturing of materials, transporting them to a site, fabricating those into parts, getting them to the job site, and then assembling and building the building. So that's a pretty significant, a third of the overall building impact is actually from those embodied carbon impacts of materials and transport. And really, the key thing on this that I don't think is starting to come in the lexicon is, the goal is to reduce carbon. It's not to reduce operating carbon, it's to reduce carbon. So really, if you only talk about operational carbon and you don't really understand embodied carbon, you're only talking about part of the solution. And this was it was a webinar I was on a couple of weeks ago. It was described really well to me. The embodied carbon discussion is we're already flying the plane, and now we're trying to build the plane as we go. So I think there's this acknowledgement in the greater community is we're still figuring this out, and that's okay. But we've got to make sure we start looking at both, because if we don't, this is kind of what I liken it to, is if your goal is to lose weight, and I say there's two paths, you can do lose a pound a week or lose 2 pounds a week. Which one are most people going to do? And this is the operational discussion, is from an ongoing basis, I'm going to lose as much as possible. So, but what if I told you at first, you got to add 50 pounds, you got to bulk up, you got to hit the gym, you got to eat protein, and then once you've added all that muscle, man, now the weight's just going to shed off. Well, long term, that second one's still the right thing probably. But what's the time frame? Well, if you have a wedding in 6 weeks, option one is probably better. You could do option two, but if your goal is to lose weight by the wedding, option two is not going to be the right goal. And that's the reality is if you look at, the Climate Mobilization Act and the Paris Accord and all these sort of things, what the targets are, most times it's a 40% reduction by 2030 in carbon usage, or an 80% reduction by 2050. That's kind of some of the New York City code. So they're time-based things. And if you really start digging into the details, what you'll see is you really have to start looking at overall carbon usage and how do we reduce that quickly. This is the sort of thing that might hear about is the time value of carbon. This is what we're talking about. Or you might hear about carbon debt. How much embodied carbon up front do you have to take on, and then how do you start working that off? This is really kind of what we're talking about when it comes to that space. So you have to include both. And just as a refresher, the first thing that I talk to people about is, well, what are glass and windows? How does it fall into this space, and how does it impact, operating carbon? So, I think most people would be familiar with these terms, but really we're trying to make the windows into better filters, and we're trying to make them into better insulators. And we only have a couple things to do that. We can use darker glass. Darker absorbing glass doesn't let as much light get transmitted in. You can use a better gas. So that what I'm showing on this bottom left is, most times in an insulated unit, there's air or argon. So when you go from air to argon to krypton, there's bigger molecules. There's less stuff to do heat transfer. And if you have a vacuum, there's no stuff to do heat transfer. You can use a better glass, or a better coating. This top left picture here is the solar spectrum. So you can see what most times we're trying to do with coatings is filter out the UV, leave in the visible daylight, and then filter out the near IR. And if you want lower than a 0.4 SHGC, you've got to take out a little bit of daylight too. So the coatings will make the filtering better, and sometimes it will redirect the heat back to the room or redirect the heat back out of in the summer. So using better coatings or more coatings on surface 2 and on surface 4 will make the performance better. And using more than one piece of glass. So when you go from single to double to triple to quad, those all make the windows better filters and better insulators. But that's really all the triggers that we have. And really all we're talking about here is how do we make the operating carbon better? That's essentially what we're talking about with this. So if I start looking into embodied carbon and what all does that mean, so first off is I think there's this conception that glass is really difficult to melt, and then windows are poor performers. They're one of the lower insulated parts of the overall window design. So if I'm an architect and I say, well, I would just want to make smaller windows, that's probably the right thing to do. But the reality is I think that's what people will find when you start digging it deeper into all these things is the embodied carbon impact of most windows is fairly small in terms of a project. And there are ways to make a little tweak on that. So a slight increase in your embodied carbon and a massive improvement in your operating performance. Ultimately that says we shouldn't have smaller windows. We should just have better windows. And there are hundreds of technologies that we already have readily available. We know how to do. We just have to demand better windows in terms of that. So I think that's what eventually we're going to see as we go through all these things. But first, let me talk about glass parity. When I compare us to somebody else that makes glass, a lot of this gets calculated with what's called an EPD, Environmental Product Declaration. So, how much energy does it take per pound of glass? And really, anyone that makes glass is pretty much in the same boat. That's why I say glass parity. Most manufacturers are, within a standard deviation of each other. And then when we take that glass and make it into windows, pretty much everybody in that space is within a standard deviation of each other as well. So, buying glass from this person or that person isn't really a great strategy to reduce your embodied carbon impact. Right now, everybody's kind of in the same boat. And really, if you want to understand, how much does glass impact the embodied carbon of a project, think about this watermelon on the right. The glass is essentially the skin on a building. And what I've seen, at least in most data, is it's between 2 to 5% on most projects is the glass impact on overall embodied carbon. By far, the much bigger piece of embodied carbon on a building is the structural stuff, the steel, the concrete, sometimes the aluminum, but those big structural elements is just much more of the mass that's in a building design, and the glass is just the skin. So we generally are a very small embodied carbon impact on a building. Maybe a triple glaze with fins and all these sort of things, maybe it ends up being 10% on a really big project. But generally speaking, the glass is a pretty small portion of the overall embodied carbon. And the key thing that I want to try and get across on this is, if we want to try to achieve some of the targets of climate change, new construction will not solve this problem. We cannot build our way out of this. You can go out and build 10,000 brand new zero net energy buildings. But if you look in the details, this bottom right blurb here is a New York City 2050 code, which they're trying to have an 80% reduction by 2050. And in 2050, 90% of the buildings that'll be in the city of New York of 2050 are already built today. So unless you have a way of reducing or improving energy performance and reducing the carbon impact of existing buildings, you aren't going to hit these targets. So I think people are just starting to figure out, like, we've got to do a much better job on existing buildings if we want to have a chance of hitting some of these targets. So, overall, when I try to explain to people on glass and how to impact your design in terms of embodied carbon, there's really a couple things that you can do no matter what choice you make, no matter what you use, monolithic or regular double glaze or anything like that. So the first thing is try to right size your glass. Don't put in way thicker glass than you need. Don't put in a 1/2 inch thick if a 1/4 inch thick will do, or 5/8 will do. The thicker, the heavier the glass. If you put in a triple laminate versus a double laminate, all that is driving more materials and costs up front. And unless you get that payback in terms of embodied carbon, don't over-engineer basically. Use better gas. When you require a better gas fill, it's a pretty minimal embodied carbon impact with a maximum return on your operating performance. So I tell people to do that. Longer life is really something that needs to be considered, because in the embodied carbon discussion, you're not talking about, a one-time use, but if you buy windows that only last 10 years, your building's going to last, say to 2050, you got another 30, you're going to have to replace them 3 times. If you buy windows that'll last 30 years, you only have to do them 1 time. So buying longer life, better performance windows really matters. And that sometimes doesn't get to the building spec. You just say, oh, it's got to meet this performance. But if the windows don't last very long, you're actually doing the wrong thing in terms of embodied carbon. Buying locally. It doesn't impact from a glass supply standpoint. We don't see this, but in your building design, you will. The further you have to ship, the more you have to transport, that all starts to go in. So what we try to say is, as you try to understand your design strategy, we can try to help guide those operating and embodied discussions. And as I start to think about existing buildings, I remember the quote, Carl Elefante from Quinn Evans, an architect in the US in DC. He was the president of the AIA, 30 years ago. I think he said that the greenest building is the one that's already built. And that's definitely the case. And I think people will start to realize how much of an impact building reuse is going to have in achieving some of these goals. But what I want to challenge is there's typically only 2 ways that we approach existing buildings today in terms of windows. So one track is, we just add secondary glazing, storm windows of some sort, inside or outside. And I would classify this as the minimum embodied carbon route. So, you add a piece of glass in a frame. It doesn't add a ton of material on. It keeps all your heritage materials, really minimizes the amount of impact aesthetically and how much embodied carbon addition you have to add to a project. But it doesn't typically massively improve your operating performance. You'll get better window performance, but not necessarily to replacement window type performance. So more the embodied carbon minimized path. And there's a lot of reasons that this might be the best solution for a project. There's no one size fits all. The other way that we typically see people treat existing buildings is they'll do replacement windows. And in the US, 98% of the replacement windows that go in are double glazed products. And, unbelievably, like 8% are actually still clear over clear. So with this, you're getting better operating performance than you typically will with a secondary glaze. But this would be, it's the path of lowest operating performance, but it's the maximum impact in terms of embodied carbon. Because not only are you taking out the original windows, you lose the heritage materials, you're landfilling that a lot of times. You're adding in new IGUs, new framing, new sash, new steel, new whatever, and then a lot of times you are taking out a monolithic glass and putting in a much thicker, heavier window, so you got to add structural support as well. So there are all these other embodied carbon impacts that you have to take. And really, these are the only 2 options that I see most times when people are considering existing buildings. So what we're trying to do is explain some of these emerging technologies that are currently available. You can buy these today, and try to explain how these address, the performance, form factor, and embodied and operating carbon paradigms that are out there today. There are great glass and glazing technologies that are currently available, and stuff that's emerging that's maybe not, mainstream just yet. But these things, we know how to do them. The science is clear. And if you start to think about how to use these, it can really change some of the ways that existing buildings kind of perform. So the first thing is vacuum insulated glazing, or VIG. So this is 2 pieces of glass, and typically an IGU is there's a 1/2 inch to 3/4 inch airspace. There's a metal spacer of some sort, aluminum or stainless steel, and it's typically glued to both sides with an organic material like a PIB. Um, a lot of times that organic seal breaks down with time, temperature, humidity, moisture, and then the gas leaks out, moisture leaks in, and it starts to fog the windows. That's by far the biggest complaint with regular IGUs. VIG alternatively, and I have a whole hour I could spend on VIG. I told you I'm a glass nerd. So VIG is two panes of glass. Instead of a big airspace, it's a very, very, very thin vacuum gap in between the two. It's typically about 0.2 to zero point 0.3 millimeters. And the vacuum's a really good insulator because there's no material in there, even at a very thin level. So what this gets you is the same or better performance in a 1/4 inch VIG unit as you would get in a 1-inch IGU. So this starts to change that thickness and form factor versus performance paradigm. The other thing that you get with VIG is this seal is a glass sealing glass most times. There's other methods as well, but that seal, because it's an inorganic hermetic seal, has the potential to last much longer than an organic material that we know breaks down. So if that extends the amount of time that you potentially can keep that window, it starts to change your how much of an embodied carbon impact you have over the life of that project. The bigger place that it does is it enables you to reuse the existing materials. So you can reuse your sash, reuse your framing. All you're doing is changing out the glazing performance. And this really, again, is a great solution in terms of performance versus form factor versus material reuse. Another product concept, which is fairly new to actually being implemented, but has been around for quite a while, is what's called a thin triple IGU. So the idea on this is the top left picture here shows how we traditionally make IGUs in Windows. So monolithic glaze, single piece of glass. Double glazed unit is 2 pieces with an airspace. Triple glaze is 3 pieces of glass with 2 airspaces. So in terms of embodied carbon on the glass, 1 piece of glass, 2 pieces of glass is twice as much embodied carbon. 3 pieces of glass, 3 times as much embodied carbon. So you think, okay, well, that's pretty straightforward. But the other thing that comes along with this is look at all the extra framing. This is all the metal work that goes along in here. So a lot more metal, a lot more steel. Triple glaze is much thicker, much heavier. Sometimes you have to change the window designs to accommodate these really heavy. You can't handle typical casement windows. You've got to have other tilt and turns and other designs. So you have all this additional other framing, and then the overall skin is much heavier as well. So sometimes you might even have to have structural support in to actually hold this thicker, heavier weighted skin. So the thin triple is you take a piece of thin glass, drop it in the middle of a double glazed unit, and then do a krypton fill. So now what you're getting is a double glazed product or a double glazed form factor that performs like a triple glaze. So this really gives you 2 gains in terms of embodied carbon. And I'll go into the first one in a little bit more detail on the next slide. But when you add a piece of thin glass to the middle, again, the way that we calculate embodied carbon is per pound of glass. So if I can have a piece of glass that's much thinner in the middle, it will have less of an impact in terms of embodied carbon of that glass. So this will have much less glass impact in terms of embodied carbon than this piece will. So that's one way. The other way is instead of having to go, when I go from a double glaze to a triple glaze out to this thicker frame, I can use this existing double glaze framing. So now I don't have to add any of those other frame and steel and structural sort of supports. It allows you to get this big change with a really minimal impact in terms of your embodied carbon. You get a much better performance. And I said I'd talk in more detail in this architectural thin glass, but glass weight is it's a simple calculation. 1/4 inch glass, 6 mil, weighs 3.1 pounds per square foot. So if you get a 4 foot by 10 foot piece of glass, it weighs 124 pounds. If I go to 1/8 inch, it weighs 60 pounds. And if I go to 1 millimeter there, it only weighs 20 pounds. So it's a simple calculation of weight. And then the way that we calculate our EPDs, and again, this I think is still in its infancy stages. And I think there's some recognition that this isn't necessarily going to be the case in maybe 10 years or 5 years, we'll figure it out. But you don't necessarily have a linear reduction in embodied carbon as glass gets thinner. It does reduce and then it probably starts to flatten out, but it's not the case. The way it's calculated right now is it's a linear relationship. So, so going to a much thinner piece of glass is going to give you much less of an embodied carbon impact. So using these thin glasses as a way to reduce your overall embodied carbon strategy, even if it doesn't reduce as much, we know long term these will actually still be good strategies to help reduce embodied carbon. So what this then leads us to is, okay, well, with these emerging technologies, what does that mean? How do we approach buildings differently? So when I take a look at monolithic glazed buildings, and the last I saw on this was in the US, 2/5 of the building stock, which building stock in the US is about 325 billion square feet of building area. That's the built environment in the US. Um, 2/5 of that, 40%, is monolithic glazed. So this is a massive, massive market. Um, Tons of buildings that are monolithic glazed. What could I do instead of the two traditional routes that I take? Well, one is I could just reglaze those buildings with VIG. And this bottom left picture shows an example of that. This is a project we did with steel casement windows in the Winston-Salem train station. And I'm working with an architect, Matt Radoon from Scott Henson in New York City. And he did a case study he presented at APT last year. And they compared reglazing steel casement windows versus replacement aluminum windows. And what he found was it's a 94% reduction in embodied carbon to reglaze those existing steel windows versus doing replacement windows. 94% reduction in embodied carbon. Now the operating carbon, it's not then an apples to apples comparison because the steel work, you have some short circuits there, so the overall window won't perform quite as well as that replacement window would. But even if you look at that, you go, okay, well, there's a trade-off. And if you add the overall embodied plus operating carbon, there's at some point where they intersect. So that's then what people really need to be figuring out. But right now, we're not even doing those calculations. We're not even really looking at it. So I think there's a case to be made, say, we know that this reduces the upfront carbon. We know it reduces embodied carbon. You got to calculate what the right thing for the building is. But we need people to start considering these alternatives because they are very, very good solutions to achieve the overall goal. And again, in certain instances, in certain projects, these might be a great idea. In other ones, we would say do something else. But one is just a simple reglaze with VIG. The other is a thin storm window. So this bottom center picture here is a 1.3 millimeter storm window, and it's got a film on it. So now instead of a 1/4 inch glass, it's got a significant less amount of embodied carbon because it's thinner. And as you add that to an existing building, you don't have to add any additional structural framing. And it gets you pretty good performance. This particular one is with a fiberglass frame as well. So really minimizes the amount of embodied carbon you need, but gets you to the same energy performance as a normal secondary glazing would. The other thing that we're seeing people starting to do, and this is sometimes referred to as overcladding. It's not a lot of times talked about in glass, but instead of what a traditional storm window is, what this is it's in situ creating an IGU on an existing building. So they'll come in and add framing and add an actual seal, so it permanently seals that other extra piece of glass onto the outside. So you don't have the traditional cleaning and maintenance that goes along with storm windows. You get higher performance than you would with a traditional secondary glaze. And then potentially this opens up the option to, once your seal fails, over time when that glue eventually starts to break down, you have the option to go in, remove that extra added piece and reglaze it. So potentially it gives you the reworkability of a product. And then potentially you can use a VIG as these different secondary glazing products. Again, it may not fit for every project, but when you can do that, you now get to triple glaze performance in a retrofit solution. So all of these are what I would call, they have the impact of a restoration project. They have a minimal embodied carbon tick up in terms of your overall project, but it really gets you to the performance of a replacement window without having to go to the whole track of doing replacement windows. And then lastly, now I'm going to talk about new approaches in terms of the double glaze design. So again, this could be in terms of restoring existing buildings. There's a lot of old failing 1970s double glazed curtain wall windows, and you could take this track with some of those buildings. But also for new construction, is you can use some of these technologies in new construction. And what we're talking about here is how do we get to an ultra performance product, but in that existing form factor, so we minimize the embodied impact carbon on the overall project. And so one way is using this kind of thin triple IGU. Another is using this product, which is called a hybrid VIG IGU. So instead of a regular 1-inch IGU, you use a VIG pane as your inboard light. And now essentially you're getting a triple glazed product in a double glazed form factor. And then again, using thin laminates as a way to lightweight and thin down the embodied carbon of what's required. It gets you to the same performance level, but it really helps you minimize the impact in terms of your overall embodied carbon. So again, these aren't maybe going to be the fix all for every major project, but if you start including some of these emerging technologies into the way we think about design and the way we think about existing buildings, these should then be a path that say we can help you achieve a lower all carbon footprint, whether it's through embodied carbon or whether it's through operating carbon. Um, and we can help you improve your operating performance as well with a minimal impact. And I think that then reinforces that, there are tons of good glass and glazing solutions. We just need to help educate people on what they are, how they work, how to include them, and think about them from a design standpoint. And I think we'll then showcase the way that glass and glazing technologies really can help achieve some of the targeted goals that we're seeing out there in the architectural world today. With that, I'll open it up to questions. Thanks again for all your time, and anything I can do, just let me know. Thanks.